AI labs like OpenAI and Google spent years perfecting LLMs. But the real breakthrough happening right now isn't better LLMs, but a shift from talking to doing. So, what turns a powerful LLM into something that can actually research, book flights, write code, or manage your entire project? AI agents. Here is the difference between an LLM and an AI agent. LLMs are neural networks trained on internet data. They are great at predicting text, answering questions, and explaining concepts, but they have clear limits. For example, if you ask, "What is the weather in San Francisco today?" a plain LLM does not have today's live data. It might confidently guess, but it isn't actually checking anything. Or if you ask it to research AI trends with citations, it cannot reliably search the web or verify sources. It is just generating text. Think of the LLM as a human brain. A brain can reason and plan, but it cannot directly interact with the outside world. It can't open a browser or send an email. Humans become powerful because the brain coordinates with hands, eyes, and external tools. An AI agent wraps an LLM with three specific components: tools to act, memory to remember, and a reasoning loop to get the task done. It is not a new model, but software that orchestrates this system, allowing the LLM to provide more value than just generating tokens. Let's look into each component starting with tools. Tools are external capabilities the LLM accesses whenever it needs extra information or wants to take action. These tools can be simple Python functions like a calculator or external APIs like search, booking, and internal company services. Each tool is defined by a schema telling the LLM what inputs it expects. When the LLM needs a tool, it outputs a structured call, showing which function or API to use and with what arguments. The agent's orchestrator runs the function and feeds the result back to the LLM. For example, if you ask, "What is 17 times 24?" the LLM recognizes it needs a calculator. It outputs a specific tool call with the arguments 17 and 24. The agent's orchestrator executes this function, receives 408, and feeds it back to the model so it can answer 17 times 24 is 408. Or consider a request like, "Book dinner for 2 tomorrow at 7 p.m. in San Francisco." The LLM asks for a web search to find restaurants. The agent calls the search tool and feeds the results back to the LLM. Then the LLM asks to book a specific place, and the agent calls a booking API with the restaurant time and party size. The LLM receives the result back and outputs a confirmation. The second key component is memory. If the LLM is the processor, memory is the hard drive. There are two kinds of memory in an AI agent: short term memory and long term memory. Short term memory is the LLM's context window. This is everything the model can see in the current conversation and the current working state. Short term memory is great for keeping track of what the user just said, what the agent just tried, and the immediate plan, but it is limited by the context length. Long term memory involves storing information outside the LLM and then retrieving it when needed. The agent can store user preferences, previous tasks, notes from earlier conversations, or company documents. When a new question comes in, the agent retrieves relevant info and pulls it into the context. For example, if you travel often, the agent stores your past conversations, which indicate you prefer aisle seats and direct flights. Month later, when you ask for a new trip, it retrieves those preferences from the long term memory into the context window to plan accordingly. The most critical part is the reasoning loop. Instead of the LLM being a one shot chatbot, this loop turns an LLM into an agent by placing it within a continuous cycle. Here is how the loop works: the LLM processes the context and thinks about the task, decides which action to run, produces the tool call, and the agent feeds the outcome back to the LLM. Instead of stopping here, the LLM reasons again. It iterates until it reaches a goal or decides it cannot proceed. A common pattern is REACT, a prompting technique that instructs the model to follow the strict thought action observation format. Imagine you ask, "Find a United flight to New York next Friday under $300. The agent enters a loop to process this. It starts with a thought: "I first need to check what date next Friday is." The LLM requests an action by outputting calendar tool. The agent runs the function and sends the result back as observation. Next Friday is October 18th. The LLM takes that observation and loops again with a new thought. Now I can search for flights. It produces a call to the Flight API tool with the date and price limit. The agent returns a list of flights as observations. Finally, the LLM concludes, found United Flight 294 for $280 departing at 10 a.m., and returns the final answer. This reasoning loop makes agents reliable. If a tool fails, the agent retries. If the request is unclear, it asks a question rather than guessing. In short, an AI agent is just a looping system built around an LLM with access to tools and memory. It reasons about a goal, plans next steps, uses the right tools, and remembers its progress to get the job done.